As discussed in the last video, there are a couple of properties of vectors, particularly when we're adding or multiplying them by a scalar. Just one thing that's important to note, you cannot multiply two vectors together. So you can add or subtract two vectors together, and you can multiply a vector by a scalar, but you can never actually multiply two vectors together. So just to go over the rules, so for vector addition is associative, which means that it doesn't matter the order you add the vectors. And you saw this on the first homework question from yesterday. So, sorry about that. So you can add B and C first, or A and B first, or A and C first, and it doesn't matter. So that means the property's name is associative. They're also commutative, which means you can change the order and it doesn't change the results. So vector addition is associative and commutative. Properties of scalar multiplication are associative and distributive. So the associative rule says that if you multiply a scalar by a vector that's already being multiplied by a scalar, you could actually just put the two scalars together and multiply them together by vector A. And the distributive property also applies, meaning if you have a scalar multiplied by two vectors that are being added together, you can distribute that scalar k across both A and B. These rules are obviously going to look very familiar because we've done lots of algebra up until this point. So I just want to give you an example of what this might actually look like. If you had 2 times 3 times vector A, that's going to end up being 6 vector A. Now we have a few properties of something called the zero vector. The zero vector is a vector that has a magnitude of 0, but it actually does have a direction. So it's distinct from just the number 0, but its direction is actually undefined. So the idea is this is a vector and not a scalar, and it just represents sort of an empty vector. If we wanted to give it some properties, you can actually add the 0 vector to another vector, and it won't change it. You cannot add a scalar to a vector. So you couldn't say vector A plus 1, but you can say vector A plus vector B, so you can add together the 0 vector with an actual vector. And likewise, if you add two vectors together and they are opposites, you will not end up with 0. You will end up with the 0 vector. So it's distinct from the number 0 because there are all these rules about when you're allowed to add and subtract and multiply scalars and vectors together, that when you add two vectors, you always get a vector. So it's not possible to add two vectors together and just get a scalar. That's why we need the 0 vector. We're just going to do a couple of examples so you can see that this really is just an extension of some rules that you are really used to. So in our example here in yellow, we're going to simplify given that we know vector x is 2a minus 3b and vector y is a plus 4b. We are actually just going to replace vector x and y with their new vectors. And then we're going to simplify like you normally would. So we're going to multiply out, distribute that 3, maybe another way of thinking that should be 9, and distribute the 5. And group our like terms. So you're allowed to put that 6 vector A minus 5 vector A together to give us just vector A. And we're allowed to put the negative 9 vector B and the negative 20 vector B together to get negative 29 vector B. We have a second example here, much the same. We have a negative 2, and then we have vector x minus vector y. And we can simplify this a little bit. So we have 2a minus an a. So we have the vector a in there, and we have 3 times vector b minus 4 times vector b, which is negative 7 vector b. And finally distribute that negative 2. So these rules hopefully look very familiar, and you've done this a lot. So I don't expect that there should be too many problems with the homework. Please be careful as you're working on the homework. If you do run into something and you really have no idea, rather than stopping, try and skip that one and come back to it. Maybe have a look at what the answer is, see if you can make sense of it that way. So good luck today, and I will see you tomorrow.